record the session. Okay, so it's now recording. Let me say it again. This is an error. The midterm test and end of term quiz is 30%. Okay? I'll make a note in the Blackboard again. Okay, and then we turn down the background music. And there are 2 labs, and I'm sure you understand by this time I do not know if we will be able to meet for the lab. Okay, as of right now, I think the whole Hong Kong is going to be doing okay at the end of the month. So we hope that we can meet for the lab sessions at least. Okay, but as you know by now, you never know how things will turn out. And in fact, of course, I myself would really prefer to have face-to-face lectures. Right? But before that happens, we will have to meet every week here online. Okay, so in principle, there are 2 labs, and I don't know if we can meet for the lab at this moment. Okay, if we cannot meet, then we will have some MATLAB assignments or bigger MATLAB assignments as a lab session. Okay? In fact, even in previous years, we intended to have one of the labs to be a MATLAB MATLAB based lab anyways. Okay. Of course, we communicate everything through Blackboard. Okay, yeah, the lab will be at EF42 if we are able to meet. Okay, supposedly there are 2 experiments, and supposedly we'll form groups of 3. Okay, yeah, you try to find some classmates if you know them already. Okay, and then it's not that urgent. The lab typically won't start at week 5 or week 6. Typically week 5 or week 6. Okay, and there are only 2 labs in this course. So the first lab is week 5 or 6. The second lab is week 11 or 12. Okay, so you don't have to worry about the lab schedule at the moment. Okay, but of course it's good to start early. So if you can, please find your friends, groups of 3, and then I'll ask you again about your grouping later on. I understand there's quite a few students here who have previously asked us for permission to take the lab in spite of class conflict with one of your other classes. Okay, so if you have a lab conflict, okay, we'll just arrange you to do the lab at some other time. Okay, let's talk about this issue, maybe at 2 or 3 weeks from now. So let's not worry about it at the moment. Okay, so I've been here for a while, so I guess I know what you have studied in previous 2 years. Okay, so of course I assume that we will have the exposure that you have at AMA courses. Okay, so you know some linear algebra, complex numbers, and some calculus. So I'll just say for now, at this moment, this course will be separated into kind of 2 parts. Right? We'll first spend a few weeks to talk about the fundamental mathematics or insights of what is signals, what is systems. That part, some of the students might find it to be a bit more mathematical and sometimes maybe feel a bit more abstract. Okay, but then after the 5th week, we will use the new knowledge that we develop, and then we will talk about actual applications in communications, okay, such as AM, FM radio, and then digital transmissions and things like that. Okay, so I've been teaching this course for a while, so I hope I have a good idea of what kind of materials, what kind of style, what kind of speed is the best for students. Right? But then please let me know if you feel there are ways to make the lecture more enjoyable and more effective. Right? Especially this is the first time I teach this course online. Okay, so I'm hoping that I'll still be able to maintain the sort of delivery style and effectiveness compared to regular lectures. Okay. Yeah, okay. For you, well, if we're doing face-to-face, then of course, don't turn on your mobile phone to ringing, okay? But then that's not relevant now. What's relevant now? It's let me know if there's some issues, some concepts that you don't find clear, okay? So let me know through your voice. You can actually speak up if you want. You can also type it out, okay? Yeah, it would be great if we can all participate. Okay, we have a few teaching assistants. I hope you'll be able to meet them in person. Meaning, I hope the restrictions of face-to-face meeting will be, will be taken away. All right. So until then, we have a group of staff that will help with the marking and then um, and the lab demo. Okay. Oh, I have a question. Let me see the midterm test and quiz. Okay. Oh, sorry. The midterm test. Let me type it here. A midterm test will be on week 7, and then the end of term quiz or test or whatever you want to call it will be at the end of the semester. Will be week 13. Okay. So let me type it out. Midterm is at week 7, and of term. Okay. How many people in a group? At most 3. Okay. All right. Um, yeah. Okay. So let's move on. I myself, I got my degrees elsewhere, and then my area is actually communications. That is why I master teach this course. Okay? So every colleague here in the department knows something in particular. So I myself happen to know a bit more about signal systems, telecom. So hopefully I'll be able to share with you some more fundamental insights, and then some of the more updated technical challenges in this area. Okay, so learning outcome, hopefully by the end, we would understand the fundamentals of signal and systems, and then we'll have a basic understanding of what it means by our communication systems, how does it operate, what are the factors that are limiting its speed. All right, so for example, right now we are conducting courses online. Okay, I can tell you these sort of technologies, these sort of applications, is not possible 5 years ago, because the connection speed, the internet speed 5 years ago would not be fast enough to support these sort of real-time video conferencing. And because every one of you is sitting somewhere in Hong Kong, or maybe some of you are not even in Hong Kong, right? But then you are able to listen to my voice almost real time, and you are able to look at the slides that I'm presenting almost in real time. Hopefully, the slides is not is smooth enough for you to feel comfortable. Okay, but this is all as a result of our continued efforts to understand what are the fundamental limits of transmitting more information, and how do we overcome them. Okay, so now this course essentially, again, it's 2 parts. One part, the first part is on the fundamentals, the basic, the underlying mathematics of signal and systems. The other part is applications to telecom. Okay, so I wanted to first get you to start thinking about telecom. Okay, what does that mean to you? So I think at 2020, I think some of these terms are rather common. For example, 5G. FaceTime. I'm not sure if FaceTime is common, but then WhatsApp is common in Hong Kong at least. I don't know how many of you use cloud services. Okay, you must have heard of fiber optics. There's still this thing called fax, where I think some of you actually might not even know what that is, and that is a great example of how our technology has evolved. Okay, because fax as a concept is not really useful anymore, because we can now scan and do a lot of things with image. We can transmit image very easily. Okay, so I wanted to get you to start to think about, now these are the things that we are talking about when we say telecom. Now I want to give you some statistics or the current status of telecoms moment. Now, this is actually a clip that is already 2 years old. I might be able to find something more recent later on. This is to get you to think about. This is to get you to think about how we are living our lives these days with telecom. Okay, so and this is what the course is about. Eventually, I want to get you to understand or the flow or the process of how our recent internet come to place. I'm sure none of you were around when email is first invented in 1995. I'm sure nobody knows what is ICQ. I hope some of you know what is MSN, as that is the instant messaging software before WhatsApp. Okay. Um, Facebook come out at 2004. Before that, there's actually a thing called Friendster. Basically, it's the same thing. Okay? But then Facebook did a much better job in security and privacy. And then video is not really a thing until 2005 when YouTube come about. That's because, as I said just now, even 5 years ago, you can't really do this online lecture. It's pretty tough. Uh, and video itself, the transmission of video, actually, because video has such a large size, okay, 10 years ago or 15 years ago, it's actually quite hard to transmit a whole video clip. Okay, so there are things that wouldn't be possible until the transmission speed is fast enough that the whole thing makes sense. Okay, Wi-Fi come out at 20 years ago, and then high definition TV, like the sort of TV that we are enjoying at home nowadays, that actually is a relatively new thing. It's only happened at 2008. I assume right now, nobody at home will have the old style analog TV. Now cloud service, it comes out at 2011, like Dropbox and Box, or if some of you use the PolyU cloud service, now that's cloud service. Okay, what's more recent stuff that you might know a bit more? It's things like IoT, Internet of Things. Okay, so for example, everything is now connected to the internet, right? Your car, if you talk about Tesla, or there are things at home such as the fridge or the washing machine or the lights, all this stuff. Supposedly, it can be now connected to the internet and then can be controlled by an app for no reason at all, in my opinion. So these are some of the ongoing trends in telecom, IoT. AR, VR, augmented reality, virtual reality, these sort of stuff, I'm sure you heard of it. Some of you, if you play Pokemon Go, so that's a classic example of AR. But I would say this stuff has not found the real application yet. Okay, so there's still no real use of these technologies as of right now. It is more like a gimmick, or it's just like a cool thing for gaming at this moment. 5G wireless, I'm sure you have heard enough of these over the past 2 years. There are more and more countries that will have 5G networks starting this year and next year. Okay, so now here's a question for you to think about. Okay, now at this moment, even in Hong Kong, I should say 2020 here, with at this moment we have 4G LTE. Some of you already have fiber to the home, okay, already. I don't, but then some buildings have already. My question to you to think about is, why do we still need faster internet connections? Is it because we want to talk to more people at the same time? Is it because we want to download more emails? Is it because we want to upload more photos? Is it because we want to download very high definition video anywhere, anytime? Or AR, VR, or do we feel that we actually it's not we don't have enough introverts? Introverts means that people who do not able to talk to do not want to talk to others. Right? Do we need more of these people, or all of the above, or none of the above? All right. So I want you to think about this for a moment, and hopefully we are able to partly answer this question at the end of the course. Okay, so I'll give you a first glimpse of the answer. The correct answer is H is actually none of the above. Okay, and we will hopefully we'll show you why we still wanted to improve communications technology, and then towards the end of the semester. Okay, so now let's get a bit more specific here. Okay, again, this course is about communications. What are the typical communication systems that we have? For example, you are all aware of copper wire, telephone. Okay, some of you, if you live with your parents, you probably still have a home phone. Okay, but then nowadays, a lot of people don't find a need to have a real phone at home because your cell phone should be good enough. Okay, wireless, obviously your cell phone. But then when we say wireless, we also actually mean a lot of other things. Right? So besides cell phones, radios is wireless. TV broadcast is wireless. Wi-Fi is wireless. Your RFID is wireless. Okay, satellite communications, those are wireless. Okay, all those we consider as wireless. Optical communications, I'm sure you know, the global internet traffic is connected by optical fibers. Maybe a lot of us have not seen a real fiber yet. That's because even at this moment, each individual home might not need an optical fiber that's to support the speed required. Okay, the speed required per each home at this moment is still not as fast that actually each home needs a whole fiber. But then some of the homes already have fiber to the home services. So this stuff is going to be a trend, and eventually I think more and more of us will have a fiber optic connection at home. Okay, now I want to talk about two examples of communication system. Now these are the discussions that sort of gets us to the right way to understand what we mean by a communication system. Okay, so the first one is a cell phone. That actually is pretty straightforward. Okay, the way we see it is a communication system has a few components, a few parts. Okay, you have someone who talks on the phone. Okay, so that's the what we call message source. And then you always have a device that convert that into an electrical signal. So in this case, it's what we call a microphone. And then the signal will be sent to the antenna, okay, of the cell phone system. Okay, so the name for the antenna we call a base station. Okay, so the signal goes through the free space in the air. Okay, so the air itself we call the transmission channel, right? The channel in which the signal is transmitted. Now at the receiver antenna will receive the signal, and then it goes to the phone of the person that you're talking to. So that phone has a device that converts the electrical signal back to a sound signal, so namely a speaker, and then you have someone who is listening to you, meaning the destination of a message. Okay, so now that should be rather straightforward. Now let's talk about some another more unconventional example. The TV system. Okay, so we see this as a communication systems. Okay, in the following way. The source of the message, it's an image or a video. Now, as we will show, video is just a collection of image shown to you in very high speed. Okay, so basically, video and image. Now we see this as the same thing from this course perspective. Okay, you have a device that convert the message into electrical signal, namely a video cam. Okay, and then this signal transmit through underground cables, and then so the copper wire cable is the transmission channel. And at your home, you have a device that converts the electrical signal back to a form that is intended for the recipient. Okay, the person sitting at home. Namely, you have a TV that convert the signal into a image or video format. Okay, and then of course you are the person who watched the TV. Okay, so here we wanted to highlight the fact that we see this is how we see communication systems. Okay? It is not just cell phone. Okay? A lot of the things that we experience that we use on a daily basis, we see that as a communication system. Okay, so this is just a summary of what we talked about just now. Okay, a block diagram of a communication system. So we have a source, okay, the place that generates a message. It can be voice, music, image, video, or actual data. Okay, you always have a device. Generally we call this a transducer that converts that message into an electrical signal. Okay, so if it is a voice, then the transducer is the microphone. If it is image or video, then the transducer is a video cam. Okay, and then once you have the input signal, the electrical signal, okay, it goes to a transmitter. Okay, so in the wireless scenario, the transmitter is the antenna and also all the components before the signal reach the antenna. Okay, it transmits the signal over a channel. Okay, so a channel for wireless, it is free space. For optical fibers, it's the fiber itself. For copper wire, it's the copper wire itself. Okay, And as we will know, as we will learn later on, once you transmit a signal onto the channel, there's a lot of things that will distort the signal, such as noise and other forms of distortions that we will cover later on. At the receiver, essentially, what they want to do is to do the opposite operation. Okay, so you got the output signal, and then you use the transducer to convert the electrical signal back to a form that is intended for the recipient. Okay, and so again, if it is a voice, then the transducer here is the speaker to convert the electrical signal into voice. Okay. All right. So now this is this is meant to be a way, maybe a deeper way or a new way to see things that you are familiar with. Okay, and that's what we mean by telecom. Okay. Now there are also certain ways to classify different telecom systems. Okay, so we talk about whether it is optical fiber or wireless communication. It can be categorized depending on the transmission media. Okay, it can be categorized depending on the characteristics of the signal itself. Okay, so you might have heard about analog and digital transmissions. Okay, so as we will show at this moment, at 2020, the only analog communication system that we are still using is AM and FM radio. Okay, everything has become digital. There's a reason for it. We will talk about why. Okay, but we will still cover briefly cover analog transmission, because that the mathematics, the basis, the idea to do that is the basis of how we build digital transmission systems. Okay, communication systems can also be categorized depending on what we call the directionality. Okay, what I meant is the following. Now, typically when we say communications, we mean two-way communications. Okay, so you talk on the phone, your friend can talk back to you, so this is a two-way communication. Okay, and messaging is a two-way communication. Okay, but then there's a lot of what we call one-way communications that are communication systems. Okay, one of the more extreme examples is we will even see traffic lights as communication system. It is actually conveying or telling you information based on which color of the light is turned on. Okay, so red means something, yellow means something, green means something. It is telling you information. Okay, so it is a one-way communication system because you cannot talk back to the traffic light. Okay, so that is a one-way communication system, which we also see that as things that we will discuss in this course. Okay, our focus, of course, this course is focused on the internal dynamics of how we convert the signal into something that we transmit through a channel, and then how we receive the signal. Okay, so regardless of, we don't really care whether the source is sound, voice, music, picture, video, whatever. Our starting point is the electrical signal. Okay, and then we talk about how we encode it to certain form to transmit through the channel, and then how we receive and recover the original information. Okay, all right, so now mathematically, the starting point of our course is a signal x of t. Right, this is typically how we describe a signal mathematically. Okay, and we will spend the time to talk about the details, how this signal should be understood, should be analyzed, and then when these signals go through a system or go through a circuit, what will we do, and things like that. Okay, some of the more detailed course outline, we will talk about certain things such as Fourier series. This is stuff that you might have briefly touched on in your AMA courses. Okay, And so in this course, we will go into a more technical detail on these things. Okay, we will talk about different type of signals, such as discrete continuous time signals, periodic signals. We'll talk about how we describe systems, linear and time invariant systems in particular is the things that we care about the most. Then we'll talk about one of the most important concept that you would learn in an engineering degree, namely the Fourier transform. The Fourier transform is something that goes far beyond electrical engineering. Okay, so these are concepts that actually will try to show how general it is, how much impact Fourier transform is to various disciplines of science and engineering. And then, so these are the part that that allows us to build a deeper understanding. This is a part that actually is more involved in the mathematics. Okay, and so once we have gone through this part, then we will talk about applications, particularly in telecom. We'll talk about AM radio. Okay, we'll talk about different ways to encode AM radio. And then we will go to FM radio. Okay, so again, now these are the basis on which we build communication systems. Okay, so we like 10 years ago we will spend like 2 or 3 weeks to talk about this stuff, but then nowadays at 2020 we just decided to take away some of the contents to make it more to reduce some of the emphasis on some of the fine details, because we have moved towards digital transmissions already. But then there are important concepts here that we need as a basis to build digital communication systems. And so that will become the part on analog communications. Okay, and then at that moment, this will be the end of the 6th week, and then the first midterm will cover things pretty much up to here. Okay, and then at the second half of the course, we will first spend some time to talk about how we convert analog signals to digital. Right? So as it turns out, your voice, your image, your sound, everything in nature is analog. Right? But then how do we convert this into digital signals and store and transmit? Okay, we'll spend some time to talk about that. Then we'll talk about digital communications, okay, and all the details, of what do you mean by bandwidth, what do you mean by bit rates, okay, how do you transmit more information, okay, what are the problems when we try to transmit more information, and then lastly we will spend some effort to understand what we call noise in communication system. That is actually the fundamental hurdle or bottleneck in limiting the speed of our transmissions. Okay, how come you cannot have a high definition 4K video on your cell phone anywhere, anytime at this moment? There are reasons behind it. It's fundamentally because of the noise in the systems that prevent us from doubling the transmission speed so that you can get an even more smooth connection. We'll try to describe the effects of noise and hopefully get a more fundamental understanding. Okay, so that basically it's the rough outline of the course. And so if time permits, we'll talk a bit more about more current challenges and then what are the ongoing developments and the technical hurdles of different types of communication systems. Now, I can tell you for now already that there's not much discussion in copper wire. This thing is becoming a thing of the past. Okay, but there are a lot of issues, a lot of people working on better wireless and fiber optic communications. Okay, so I'll talk a bit about fiber optic first. Okay, so we have improved our transmission speed constantly. This is just to give you some context. Okay, 15 years ago we are able to transmit maybe 10 gigabit per second. and then slowly and slowly at this moment, yeah, there are experimental research that shows we are able to transmit 1 terabit per second signals. So 1 terabit is 100 gigabit, sorry, 1,000 gigabit per second. Okay, so this is a pretty amazing number, and we will get to understand what exactly it means later on. These are some of the landing sites for Hong Kong. So basically, all your traffic that goes up to Hong Kong, that goes up from Hong Kong, goes through these few sites. Okay, so there are optical fiber cable here that connects to different places in the world. All right. We talk about different types of different layers of communication systems. Now there are telecom systems that connects major cities in different continents. For example, here to the US. Okay, there are systems that connect different sites in a city. Okay, so for example, in Hong Kong, there are few major what we call central office switches. Okay, that accumulates that where all the traffic goes to these few major sites, and then either they circulate around Hong Kong or they go out to overseas. And then on a smaller scale, you have what this thing called access network. Okay, so these are the stuff that it's like for example, fiber to the home is an example access network. Okay, and then lastly, these are local area networks. Is something that I think most of us will be familiar with. Okay, your home router essentially builds a local area networks. Our PolyU on-campus connection, it's somewhere between a local area network and an access network. Okay, so the point here, it's different types of systems face different problems. For example, for the larger like intercity sort of links, you would need very high performance. Okay, but then for these local area networks, okay, you would actually need low cost components. For example, you don't want to buy a router that costs $1,000. Okay, and turns out to make components that are cheap enough itself is a technical engineering challenge. Okay, so therefore in telecom research, in fact, it is true for all engineering research. There are always two categories of problems. Okay, you either work on improving the performance of whatever you are working on, or you actually try to reduce the cost required to build a certain system with a certain performance. So both of them are important research developments. Okay, all right. So I wanted to talk about some of the latest research challenge here in telecom, just to give you some context and some relevance of the things that we would talk about. Okay, as of this moment, we think that there are a few aspects that is driving the demand for faster connections. Okay, the first one is to support increasingly what we call dynamic internet traffic. Okay, so what that means is we have our mobile phones, and then we have our iPads or other tablets. Okay, and then we are increasingly more frequently try to download more and more data. For example, you would want to download higher resolution videos. Okay, your IG or your Facebook posts and all this sort of stuff. You are essentially requiring downloads at faster and faster speed. Okay, and also because each and every one of us, actually our internet traffic pattern is what we call dynamic. Right? So we don't need to download a high definition video for a consecutive 2 hours. Right? Sometimes we just need a very high speed connection for 5 seconds, right? because I wanted to download some video posted by my friends. Okay, so that's what we call dynamic internet traffic. And so here comes the problem. The problem is that actually our network is not built for that purpose. Okay. Let me see. So now here's what happens. Our network is never built for that purpose. Our network is built for very static traffic flow. Okay. And also another issue is that our internet traffic pattern is more towards 2 or 3 companies increasingly. Okay, because in Hong Kong, for example, you will know that YouTube belongs to Google, WhatsApp belongs to Facebook, and your IG, I think it belongs to Facebook. So essentially, like in Hong Kong, our internet traffic pattern basically surrounds 2 or 3 companies at most. Okay, so that actually creates an issue where the way we build the internet actually is not meant to support this sort of traffic patterns. Okay? And so this is one of the upcoming challenges recently. Okay. Another challenges in this decade, it's you have heard, I think you have heard of it before. Okay, so basically wireless. Okay, so this is just a picture to get you to think about how much bandwidth is required for everyone to take a video of the important moments of this couple and send it to everyone else all over the world. Now that kind of moment, if you want to capture it for all your friends and families, it actually requires a pretty high bandwidth. Okay, and so that actually is becoming more common, and that actually would impose a pretty hard constraint on the technology, and that is partly why we would need to build better telecom systems to support these sort of scenarios. So this is to illustrate the evolution of wireless communications, meaning the coverage area of each antenna actually becomes smaller and smaller when we go to from 1G to 4G. And here, this is just meant to show all the antennas are actually connected through fiber anyways. Right? So the backbone optical network also plays a big role in wireless. Okay? As we will show later on, even when you talk on on a cell phone, most of the time your signal goes through some optical fiber cables. It's only at the last section that it is transmitted through the antenna. Okay, so nowadays the optical fiber communications and wireless basically a lot of times are part of the same network. Okay, another ongoing challenge that's something that we discussed just now a little bit. Increasing popularity of Internet of Things, AR, and VRs. Okay. Again, at this moment, I still don't feel we have found a killer application for these things yet. But then this has been here for a while, and it's getting more and more common. Right? But then it's still not at a point where everyone needs that. Okay, all right. So if time allows, at the end we'll talk about some of the research activities that people are doing, including our own, and hopefully that will give you some context of how knowledge is evolving, what is the state of the art in the whole world at the moment, and for some of you who are interested in these topics furthermore in greater detail, we might be able to talk about final year projects and things like that in next year after the course is completed. Okay, so now this is a very long introduction to the stuff that we will talk about. I hope that gives you a good background and good motivation of what we are going to discuss. Okay, so now I wanted to take a few minutes break here, and then we will start to talk about the technical details. Okay, so let's say we'll take 5 to 6 minutes break. You can, go get your food, or you go to the washroom or whatever. We'll come back at around 1:30, and then we'll start to talk about the technical details. Okay, all right, thank you. I'll just log off right now, and I'll use another computer to log on. Okay, I'll see you in 5 to 6 minutes.